Okay, volume of pyramids and cones. You guys watching this for Honors Geometry BC. I'm taping this right now, doing my Geometry AB students. So you'll see me calling on students using the random number generator. So just deal with it. Okay. Volume of a pyramid. Also, I don't know if I mentioned this because I think I handed everyone formula sheets. You also have a formula sheet in your packet. It's towards the end. All right, not sure if I mentioned that or not. All right, so if you want to take a look right now, take a look at volume of a pyramid, and what are we looking at? 1/3 base height. Very familiar, right? Everyone remember, I cover up the 1/3. What's that a volume for? Prisms, right? And this is exactly what it means is if you take a prism and a pyramid with the same height, and let's say you fill one pyramid up with water, you can fit 3 of them into the other prism. That's what that 1/3 comes from. All right, 1/3 BH. Here we go. Quick example. There is an arena in Memphis called the Pyramid, by the way. That's no joke. The area of the base of the pyramid is 300 square feet. Its height's 321. What's the volume? Can you guys refresh my memory? Just pretend I wasn't here yesterday. What's big B here? Area of the base. Yep. Now, I also have to talk about this as well. What's H? Whoa, easy, because I'm only talking about one base now. Well, this is just H. This is height. So am I talking about slant height? No, I'm talking about you're up at the apex of that pyramid. You drop that rope down. There's your Mission Impossible height. That's what I'm looking for here. All right. Please do not confuse this with slant height. All right. All right. So if I want to find the volume of this one, 1/3 BH. I told you the area of the base, 300,000. So I'm just going to plug it in. 1/3. We don't have to calculate it. It was given to us, 300,000. And the height was given to us as 321. I'm going to highly recommend you use the darn fraction template, please. Not only today, but tomorrow when we go into spheres, you will have another fraction as part of the volume as well. And we end up being, I don't think there's need for any rounding directions. Anybody want to try to say that number without saying the digits alone? 32 million, yep, 100,000. Yep, cubic feet, remember, we're doing volume, cubic feet. Questions from you guys, going. Okay. I want to make sure we're pretty solid here. Okay, find the volume of this pyramid. 1/3 BH. Can somebody take care of the base right away? Volume of the area of the base. 10 by 10, right? So 10 times 10. Okay, hey, I know surface area, you put the slant height in there. But this is height of the pyramid, the altitude. That's not drawn in. That is not drawn in. That's that distance from the apex coming down. But remember, it does form a right triangle. Anybody want to let me know what that leg length is going to be? 5, half the base, yep. And yes, you can do Pythagorean theorem to find the height. 8 squared plus 5 squared equals 13 squared. And the height should end up being H is 12. All right. And then we calculate away. So again, don't get confused with volume. I'm not using the slant height. I'm using the actual Mission Impossible height. 400 cubic inches. Next up, upside down pyramid, huh? Area of the base, 32 by 32. Can I use that 34 with the height? Can I use that 34 in the height? No, what is that height right now? That's the slant height. All right, I need to, ooh, are we going to be okay doing it upside down? What's half here? Not 30, I don't want to use 32. What do I want to use? 16, yep. So h squared plus 16 squared equals that slant height squared. Got the height? Not really relying on the numbers today. Got the height? 30, yep. Nice whole number here, 10,240 cubic inches. Anything before we go cylinder? I mean cylinder, how about cone? Excuse me, anything before we go cone? Cone it is. Got the formula? It is 1/3 BH, but the B is a circle, so 1/3 pi r squared times the height. All these volume formulas right on your formula sheet. Do they give you 1/3 pi r squared height, or do they give you 1/3 BH? Good. They used to just do 1/3 BH. Ice cream cone, all right? Ice cream cone. Ice cream cone. 7 centimeters tall, 4 centimeters in diameter. How much ice cream could fit entirely? Quick question here. I know this is a whole volume deal, but what up? It doesn't. It does say find the volume. Never mind. About how much ice cream can fit inside the cone. So that would tell me even if it didn't say find the volume, I'm finding the volume because I'm going inside the cone. Diameter of 4 and a height of 7 centimeters. And you guys, a couple of you guys have been asking me this a lot. If it doesn't say slant height, you can assume it's the Mission Impossible height. All right? So volume 1/3 pi r squared times the height. 1/3 pi. What's the radius here? 2 squared and the height of 7 I gave you. And I do have rounding directions here, nearest whole number. Get about 29? Cubic centimeters. Okay, any issues? All right, I'll do this first one with you, and I'll let you go on your own for the second one. There's 2 directions. I want one answer left in terms of pi, then convert it to the nearest tenth for me. All right, so leave your answer in terms of pi, convert it to the nearest tenth. So let's go terms of pi first. Radius. 5, yep. Squared. And can I use that 12 or do I have to use pi fag? You can use that 12. Yep, that's the Mission Impossible height right there, 12. I would need to use pi fag for the slant height. Okay, in terms of pi here, and I know algebraically we're still having an issue with it. Guys, just drop the pi into the answer. What's left? 1/3 times 5 squared times 12. Okay, I don't touch the pi button when it's in terms of pi. And when you multiply those 3 values, it ends up being 100 pi cubic inches. Now part B is, okay, now take 100 pi and let me know what it is to the nearest tenth. – 314.2 cubic inches. Yep. All right, I'll pause this right now. Go ahead and try out number 2 on your own in terms of pi and nearest tenth. Okay, part A, volume, 1/3. What do you guys have for your radius? 8. Yep, how'd you get 8? I don't see an 8 up here. Pythag, good. 15 squared plus the radius squared and the slant height squared. Good, perfect. 8. And then the height would have been 15. Drop that pi down. What are we looking at? 320 cubic inches. And then when you converted it to the nearest tenth, I'll take care of this, 1005.3 cubic inches. All right. Questions? And finally, can you work with the volume? Okay, can you work with the volume? Volume of a cone, 96 pi. Find the diameter. I know you guys can help me. I don't have a diameter, though, in the formula. What do I have, though? I have a... I meant I don't have a here you go. I don't have a diameter in the formula, but what do I have that can get me to the diameter? A rate. I can't find the diameter in the formula. Everyone agree? I can't find the diameter in the formula. What can I find that'll get me to the diameter? Radius. Okay, so that's our goal right now. Get r squared by itself. So I have 96 pi for the volume. 1/3 pi, going to solve for r, times the height of 8. Okay, on the right and the left-hand side are both what? Pi, so eventually they're going to cancel each other out when I divide by pi, so I'm just going to get rid of them now. 96 equals 1/3 r squared 8. Now, algebraically, I want to see where you go from here. Steps I can, because there's a bunch of them, really. There's no one. What do you guys got? Okay, that's fine. What's that? I can divide by 8. I can multiply by 3. Either way is going to get me there. So I'll multiply by 3. And you got to help me out here. I did it a different way. 288 equals 8r squared. All right, on both sides now, get rid of the 8, divide by 8. You end up with 36 here. 36 equals r squared. So your radius length will be 6, meaning your diameter length 12. Now, a couple of you did this on the quiz. 12. Is this area or volume I'm finding? It's just, no. It's just the length. That's it. So there's no reason to square it or cube it. It's just going to be 12 centimeters. All right, it's not area, it's not volume. We leave it at that. All right, questions? Okay, I'm going to change paths here. I'm just going to let you go to your homework, all right, instead of doing a couple of these Regents problems. Honors kids, you can go to your homework as well. You can move around if you want, sit with other people and try it out.